This lesson is on changing from degrees to radians and from radians to degrees, and also we'll be looking at how to find the area of the sector of the circle. The first few pages in this PowerPoint are the radian activity that we were going to do on Friday, but due to the change in our schedule, we did not get to do that activity. If you want to try this activity on your own, please go to the website and look at the PDF of the PowerPoint, and you'll be able to go through and do all the steps to discover the conversion factors for how to change from a degree to radian. I'm not going to do that in this video. If you're interested in that and you've looked at it and you're struggling with it, please come see me and we'll work on it after school. Right now I'm just going to go in and go to the conversion factors. So, the first thing that you should already know about a circle is that a semicircle, which is half of a revolution around the circle, has a degree measure of 180 degrees. From the radian activity, we were going to discover that this is pi radian. So 180 degrees is equal to pi radian. The second thing that you already know is a circle is one full revolution, and that's equal to 360 degrees. And that would follow, if 180 degrees is pi radian, then 360 degrees would be 2 pi radian. So one complete revolution around the circle is equal to 360 degrees and also equal to 2 pi radian. So let's discover how we're going to use this information. If 180 degrees is equal to pi radians, if I divide both sides of this equation by 180, I will get 1 degree is equal to pi divided by 180 radian. That is my conversion factor, and I'm going to be able to use this to change from degrees to radians. And it also follows that if I were to take this same equation, 180 degrees equals pi radians, and divide both sides by pi, I would get the conversion factor 180 degrees divided by pi is equal to 1 radian. This will be my conversion factor for converting from radians to degrees. So now let's look at an example. We're going to convert 135 degrees to radians. So I'm going to first of all pick which conversion factor I'm going to use. I want to use pi divided by 180 because right here I want my degree to cancel. So I'm going to have 1 degree in the numerator and 1 degree in the denominator so that those degrees cancel or divide out, and then that's going to leave me with 135 times pi divided by 180. That will be my radian measure. However, 135 divided by 180 can be simplified to 3/4. Please notice here that I want the pi to remain in the answer. I do not want you just to type into the calculator 135 times pi divided by 180 and get a decimal answer over here. I would prefer it stay in fraction form, and I want the pi in the answer. Now let's try converting negative 2 pi divided by 3 to degrees. This is radian because it doesn't have a degree sign and it doesn't have any word behind it. So, in trig we tend to not write radian when we don't have to. So, negative 2 pi divided by 3, changing it to radian. We're going to use our conversion factor, this time 180 degrees divided by pi. This gives me 1 radian. So I can see that I would like for my pi's to cancel. So that's why I knew to put 1 pi in the top and 1 pi in the bottom. Those are going to divide out, and I'm going to have negative 2 times 180 divided by 3, which is negative 120. If I'm going to do this in my head, I'm going to look at this and say 180 divided by 3 gives me 60 degrees times negative 2 is negative 120. That's, to me, the quickest way to do that without a calculator. All right, now let's look at the area of a sector. Here is the formula for the area of a sector. The area of a sector is 1/2 the radius squared times theta. A here stands for the area of the sector of the circle, r is the radius of the circle, and theta is the central angle. And this central angle must be measured in radian. Let's look at an example. Find the area of the sector of a circle of radius 2 feet formed by an angle of 30 degrees. Round your answer to 2 decimal places. So first of all, I know I'm going to use the formula for the area of a sector. 1/2 r squared theta is going to give me my area. And I'm going to remember that theta must be in radian. My radius is 2 feet. My theta is 30 degrees. Remembering that it must be in radian, I have to change 30 degrees into radian. So 30 degrees times pi divided by 180, so that my degrees will cancel, gives me pi divided by 6 radian. Now I can proceed to put my information into my formula. So I'm going to put 2 in for r and pi divided by 6 in for theta. 2 squared is 4. 4 times 1/2 is 2. 2 pi divided by 6 reduces to pi divided by 3 feet squared. But because this problem asked me to round my answer to 2 decimal places, I know that I don't have to keep the pi this time. I can go ahead and type into my calculator pi divided by 3, which is 1.05 feet squared. Nothing too difficult in this PowerPoint, so I hope that you'll be able to use these examples and get your homework done. Thanks. Y'all have a good weekend.